Okay, this is the P2 paper from January 2024. It's question number 8, and as you can see by looking at this is a proof question, algebraic methods. It's proving by counterexample for part 1 and then proving by exhaustion for part 2. So let's have a look at part 1. Part 1 says, can we use a counterexample to show that the following statement is false, that the following statement doesn't work? N squared plus 3n plus 1 is prime for all n contained in n like that. That means the natural numbers. Natural numbers are like the counting numbers. So if I'm going to prove by counterexample, I've got to find a value of n so that this doesn't work out to be a prime number. What I generally tend to do with counterexample is just start with, I'm going to start with n equals 1 and see what we get when we're doing it. So 1 squared plus 3 lots of 1 plus 1. What does that work out to be? Well, that works out to be 5. So that is prime, that's true for that one. Let's try 2. So 2 squared plus 3 lots of 2, that's 6, plus 1, that works out to be equal to 11. That's prime as well. So we'll go for at least a fair few to see if we can find the one that it doesn't work for. 3 squared plus 9 plus 1, no, that's still prime. That works out to be equal to 19. Let's keep going. 4 squared plus 3 lots of 4, that's 12, plus 1, so what's that, 16, 28, 29, still prime. And I won't do too many more before I would actually start thinking, right, is there something that I'm missing as I'm going through this? 5 squared plus 15 plus 1, 41, still prime. I'll try one last one, 6 squared plus 3 lots of 6 plus 1, and actually that does work out to be a not prime number. That's not prime, and so not true for n equals 6. Not true for n equals 6. When we were looking at those values then, when I was going through, after a while I might just actually stop and have a think about it and say, am I missing something? Does it have to be, a multiple of 2 and 3 or a multiple of 5? Depending on the scenario, there wasn't anything particularly complicated about this one, but I'd certainly, as you saw, be resilient enough to try quite a few before I'd start stopping and just thinking, am I missing something that I need to check the values that I'm trying? Okay, on to part 2. Part 2 says, use algebra to prove by exhaustion that for all natural numbers, n squared minus 2 is not a multiple of 4. Okay, yeah, I'm going to be able to do that one then. What I will try and do, if I'm proving by exhaustion, one of the things that I do is I'll try even numbers and then odd numbers. And if it's true for even and odd, then it's true for all numbers, isn't it? So that's a quick way of getting proof by exhaustion 1 done. So let's, what we're trying to do, n squared minus 2. And we want to show that it's not a multiple of 4. Okay, assume n is even first of all. So if n is even, then n can be written down as 2k. So that means then that n squared minus 2 can be written down as 2k squared minus 2. Well, that works out to be 4k squared minus 2, and then I'm trying to show that this is not a multiple of 4. Well, that's easy enough to do now, because this is 4 lots of something minus 2, so 4p minus 2, and clearly that's not a multiple of 4, because 4p is a multiple of 4, so this is not a multiple of 4. Multiple of 4, might need to just change the handwriting for that bit, not a multiple of 4. Let's try it for n being odd. So assume n is odd. So then I'm going to write n is 2k plus 1. You could do 2k minus 1, but 2k plus 1 seems to be the easiest thing to work with. So n squared minus 2 will be 2k plus 1 squared minus 2. Take your time to multiply out 2k plus 1 all squared. 2k plus 1 times 2k plus 1. I know what that is anyway. So that's 4k squared plus 4k plus 1 minus 2. So what does that tidy up? Well, that tidies up to 4k squared plus 4k minus 1, which is 4 lots of k squared plus k minus 1. And why did I write it like that? Because then that's 4 times something minus 1, 4p minus 1. And just like with the last one then, this is not a multiple of 4 either. So if we got the odd numbers are not multiples of 4 and even numbers are not multiples of 4, I do want to say this then, so I've now proved it. So therefore, n squared minus 4 is not a multiple of 4 for all n contained in the set of natural numbers there. I just want to make sure that I have actually finished off the statement. There's a proof. Try and make it really clear to the examiner that you do understand what's going on. Okay, so hopefully that one makes sense to you all.